Okay. So, uh, polymerization. Polymerization. As I told you, cracking. Cracking means when you are going to break down a larger molecule into the smaller ones. Okay. So, the demand for petrol is high, but the supply is very low. Okay. We are not producing as much as petroleum products from fractional distillation as we need. So that's why we have to do cracking. So polymerization is the reverse of cracking. In cracking, you are going to break down the large molecule into the smaller one. But in polymerization, we are going to combine the small molecules to form a large molecule. Okay. So poly means many. Poly means many, or mer means part. Mer means part. Zation means process. So as you know that, okay, the process in which a small molecule, that is called monomer. That is called monomer. Mono Monomer. To form a large molecule, that is called polymer. That is called polymer. Okay. That is called polymer, known as polymerization. Okay. Known as polymerization. Right. Known as polymerization. Okay ji. So this is a smaller one. Okay. This is a smaller one. And then again you have a smaller molecule. And then again you have a smaller molecule. Then again you have a smaller one. Okay. So when they are going to join together, so they are going to form a large molecule that is called polymer. So this is the polymer, and these are monomers. That's it. Okay. So uh, obviously this reaction is not possible at standard conditions. Higher temperature and higher pressure is required. Sometime catalyst is also required. Okay. Sometime catalyst is also required. So, uh, let's suppose I have ethene, like different molecules of, you can say 100 molecules of ethene I have, and I'm going to join them together at high temperature and high pressure. So how can I join different ethene molecules, and how can I form a polymer? Basically, you have to break down the double bond. Okay, you have to break down the pi bond so that the small molecules may join with each other, and they would be forming a large molecule that is called polymer. Let's suppose I have C double bond C, then H, then H, and then H, and then H. Again, I have ethene molecule. Okay. Let's suppose this is another molecule of ethene. 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 And this is another molecule of ethene. So I'm going to join like many monomers together, and you will see that every monomer has a pi bond, that is this, and this. And obviously as a result of this, they will be joining together. just like that. You can see a double bond is going to break down. Double bond is going to break down in this manner, and they would be forming a new bond. They would be forming a new bond. I'm representing this with different color. They are going to form new bond. So this bond is between the two monomers, and ultimately continuously I have different many monomers. Okay, so this is called polymer. This is called polymer. This is called polymer. Continuously, we have a lot of molecules, you know. So, in short, I can represent this. Okay, shortly, I can say, okay, I have n numbers of, I have n numbers of ethene molecules, n numbers of n bole to it may be 100, it may be 200, it may be 500, it may be 5000. So I have n number of ethene molecules that is going to join together at higher temperature and higher pressure, and they would be forming a polymer. Okay, they would be forming a polymer. You will see single covalent bond. Okay, so I can show a continuous chain. I can show a continuous chain on left hand, right hand side, and this is N. This is N. So this is the shorthand representation to represent the polymers. This is the shorthand representation. Whenever the examiner would be giving you the monomer, so in this way you would be joining them together and you would be forming this polymer. That's it. Okay. So you would be given a different monomers. Let's suppose in some cases you would be provided this monomer that is chlorofluorocarbon, like CH. Uh, you can say let's suppose polytetrafluoroethene, PTFE. Okay, PTFE. That is this CF2 and then CF2. This is your monomer. You have to form a polymer. You have to form a polymer. So you are supposed to write down the structure of this molecule in a proper manner so that you can combine and then you can form a polymer. तो आप इसको कैसे बनाओगे? C double bond, then C, then F, फिर F, then F, then F. Ultimately, I have a lot of monomers, so I'm representing this by N, and as a result of this, they would be forming a polymer with a single covalent bond, okay, and with a continuous chain, with a continuous chain, okay. So this is the polymer, and this was the monomer. That's it, okay. And in some cases, they would be giving you polymer. They would be giving you polymer, and you would be identifying the monomer by looking at the polymer. So they may ask in a reverse way. Okay, तो कभी मोनोमर से पॉलीमर, कभी पॉलीमर से मोनोमर, तो वो फिर देख लेंगे हम पास पेपर्स करते हुए. ओके. So now you can see कि some questions we would be doing from paper 1 and some questions from paper 2 to get an idea okay, how they are going to ask different questions from this chapter, that is hydrocarbons and introduction to organic chemistry. Okay, so this is 24. Student X stated that the 17 carbon atoms in the four rings all lie in the same plane. Student Y stated that this molecule displays cis-trans isomerism at the carbon-carbon double bond. Which students are correct? देखो इसमें let's suppose I'm considering this first, this is easy. Okay, student Y is saying that this molecule displays cis-trans isomer. I told you the two conditions for the cis-trans isomer. The condition was that there should be double bond between the carbon-carbon atom. Okay, there should be double bond between the carbon-carbon atom, or different groups are attached on the same carbon atom. Different groups are attached on the same carbon atom. Different groups are attached. Okay, different groups are attached. So okay, different groups to attached hai. That's it. But the thing is that the double bond is present in a ring. In the ring, cis-trans isomer is not possible despite you have double bond. Despite you have double bond, so cis-trans isomer is not possible. So totally student Y is incorrect. Totally student Y is incorrect. Okay. Can you tell me student X is correct or not? Student X is correct or not? Yes. What do you think?
Sir,
Student
what do they
X
mean by same plane?
ज्योमेट्री से रिलेटेड है ये ज्योमेट्री से रिलेटेड है like if you can see the single covalent bond if you can see the single covalent bond so the geometry would be tetrahedral the geometry would be tetrahedral and if you can see the carbon carbon double bond so the geometry would be trigonal planar so the geometry would be trigonal planar so you can see in this some carbons are single covalently bonded. Okay, some carbons are single covalently bonded and some carbons are double covalently bonded. So what do you think? They all lie in the same plane, yes or no?
No, sir.
No.
No. So it
So
be
it's
B?
exactly this is B. This is B. Okay. तो मतलब आप you can take an idea कि भाई किस तरह इनका difficulty level है. So you have to think accordingly. You have to think accordingly, basically. Okay. Now see this. Can you tell me how many chiral centers are there? Yes. So chiral center. This is chiral. This is chiral. This is chiral. They are asking. In addition to those chiral centers marked by an asterisk, how many other chiral centers are present in the cortisone molecule? This is chiral, this is chiral, okay, this is chiral, right? This is chiral, okay. Three chiral centers, okay. Three chiral centers, okay. One, two, three, three chiral centers. डबल बॉन्ड का chiral center नहीं होता डबल बॉन्ड वाला कार्बन is not a chiral center. So this is not, this is not, and this is not, this is not, and this is not. Okay. So three chiral centers are there. Okay. Three chiral centers. The formula shows the repeat unit of an addition polymer. Now see this question. They have given you the polymer. They have given you the polymer and they are asking the correct name of the monomer from which this polymer is made. So to identify the monomer, you are supposed to draw the structure first, then you can identify, okay, what is the monomer, and then obviously you can give the name to the monomer to find the correct option. So let me write down the structure of the polymer, and they are asking okay, the formula shows the repeat unit of an addition polymer. Okay, so C double bond C, देखो एडिशन है तो C डबल बॉन्ड C would be mandatory, obviously बात है ना कि CH and then CH3 then CH and then CH2 CH3. Okay, this is the structure. This is the structure for this polymer. Okay, to this polymer. Ultimately, it is the polymer. There would not be a double bond. Okay, but I'm going to make a monomer. I'm going to make a monomer. So I have to write down the double bond over here. So can you tell me the name of this compound? Yes. Yes. To make it easy, I'm
Sir,
supposed to
please show E.
I'm supposed to draw in this manner. I'm supposed to draw in this manner. To make it easy, I'm supposed to draw the structure in this manner. So what do you think? What is the name of this compound? Yes, it's one, two,
Pent
three,
2E.
four, five. Pent-2-ene. Exactly. So the C is correct. C is correct. It's pent-2-ene. C is correct. Okay. Uh, Geraniol and nerol are isomers of each other. Which type of isomerism is shown here? So, what do you think? Which type of isomer is shown over here? First of all, chain, then
Geometrical.
geometrical.
B.
How? Like
It's show cis
like this. Okay,
yeah.
exactly. Good. So this is cis trans isomer. Good, 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 good. Okay, 25. Can you tell me 25?
So hydrolysis.
Hydrolysis.
या नहीं
ओके, हाइड्रोलिसिस। हाँ जी, क्या कहते हो? हादिया, हफ्सा, उस्मान, समी, क्या कहते हो? शाफे, सुमोना, उमना, जुमर,
Sir, I think it's
जुमर।
reaction because one product is formed.
uh, देखो, it's not acid base, confirm, it's not acid base,
there
this,
is an
it's
addition.
not hydrolysis, it's
Reaction
not
because one
hydrolysis, it's
product
not
is
substitution.
different.
Exactly, only one product is formed. Only one product is formed, that's the reason. Only one product is formed. अच्छा जी, okay. See this. Which compound has the greatest number of stereoisomers? Number of stereoisomers.
D.
So first of all, you have to. Oh my God, इतना shortcut भाई कौन है ये? बना तो लो पहले. सबसे पहले तो obviously you have to make the structure, you have to draw the structure, and then you have to see a stereoisomer has two types. Stereoisomer has two types. Number one is cis trans, and number two is the optical isomer. So all together he is going to ask. Okay, he's asking all together. So you have to draw the structure of each and every option, and then you can see which is the structure in which there is more number of stereoisomer. I'm drawing the first structure. You can see this. Okay, this is hex 2-ene, right? 1, 2, 3, then 4, then 5, and then 6. Okay, and 2 hexene and 2 methyl. This is the structure for this compound. Okay, so can anyone tell me, is there any chiral center in this? Yes or no? Is there any chiral center? Hmm?
No.
Exactly. There is no chiral center. No chiral. So what do you think? It would give you cis trans, yes or no?
No. Oh, sorry, sorry. Yes.
Exactly. No, no chiral center. No cis trans.
Optical, right, sir?
Sir, why not?
No cis trans. Because the reason is that on the same carbon, same groups are attached. So cis trans is not possible. Yes or no? ऐसे ही है ना भाई यही बताया था ना मैंने कि for cis trans there should be double bond but not only the double bond but also different groups are attached to the same carbon atom to the double bonded carbon atom to the double bonded carbon atom. Okay, yes, हाँ, okay, आगे चलूं, जल्दी बोलो। आमना, दुआ, ईमान, हादिया, हफ्सा, उस्मान, समी, शाफे, जिमोना, साला, जैना, जुमर। यस, आर यू गेटिंग दिस? यस, जल्दी बताओ।
Yes, sir.
हाँ, okay.
Yes.
So then question, then option B में, then option B में they are saying 3-methyl hex 2-ene, 3-methyl hex 2-ene. I'm going to draw the structure for 3-methyl hex 2-ene. So hex is again the same thing. Hex is this, okay? This is hexene, this is hexene, but the double bond is at the same position, but they are saying it's 3-methyl. Rather than it's 2-methyl, it's 3-methyl. So I would be writing like this. This is 3-methyl. So what do you think? Is there any chiral center? Yes. Is there any chiral center? Yes or no? Jaldi. No, there is no chiral center, bhai. No chiral center. क्योंकि क्योंकि double bonded carbon is not a chiral center. It cannot be a chiral
Does
center.
it mean
Three hydrogen
geometrical?
atoms. Yes, geometrical isomer is possible. Cis trans is possible because on the double bonded carbon you have different groups attached. You have different groups attached. Different groups attached. So that's why cis trans is possible. So I'm going to write 2 over here. 2 over here. 0. No isomer. Two isomers are possible. One is cis, one is trans. You're not supposed to draw. Obviously, obviously, it's 100% surety that it's going to make one cis and one trans because I told you one double bond is equal to two isomers. One is cis and one is trans. So, and then you are supposed to check option C. You are supposed to check option C. They are saying 4-methyl hex 2-ene. So the CH3 is attached on the fourth carbon atom, like this carbon atom. Again, I am saying that. Again, I am saying that. Uh, 1, 2, 3, 4. So only one hydrogen is attached over here. What do you think? Okay, chiral center is there or not? Chiral center, yes. Chiral center है या नहीं है? Yes, है ना भाई, है ना? One, then two, then three, then four. Different groups are attached. Bhai, this is asterisk. This is your chiral center. This is your chiral center. Okay, this is your chiral center. If you have a chiral center, so you know there would be two isomers. Okay, like they would be mirror images of each other. And can anyone tell me um, along with the chiral center, geometrical isomer is possible or not? Geometrical isomer, yes. Is there any
Yes,
possibility
sir.
for exactly? So 2 plus 2 is 4. It's going to give you the 4. It's going to give you the 4 isomers. 2 cis, Sorry, one cis, one trans, and the rest of the two isomers are mirror images of each other. So four. Then you're supposed to check option D. Option D. They are saying 5-methyl hex 2-ene. 5-methyl is this. 5-methyl is this. Simple. 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 H. It's H. And rest of the things remain the same. Okay. Yes. What do you think? Is there any chiral center? Chiral, chiral, chiral. Yes. जल्दी बताओ chiral है या नहीं है भाई?
नहीं.
No, there is no chiral center. No chiral. No chiral. Ultimately खुद ब खुद कम हो गया यार. So option C is correct because they were asking which compound has the greatest number of stereoisomers. I would say option C. So you can see K this question would be spending you a lot of time, but if you have a good grip on isomerism and naming of organic compounds, so it would be very easy for you. Right now I'm teaching you, so that's why it's taking time, but when you would be doing individually, so ultimately hopefully it won't be taking you a lot of time. Okay, so because all the options are exactly the similar, just you have to change the position of the methyl group. Okay, that's why. Yes. Can anyone tell me if you remember we were doing this? We were doing this, okay? Vitamin A contains retinol, and just you have to say, okay, they are saying after these bonds have been broken, further oxidation of the fragments may occur, as I told you, right? If you remember. Under which conditions is the acidified KMNO4 used, and what do the final oxidation products include? पहले आप करो, then I am going to say कि आप किस तरह से करोगे इसे. Yes. First of all, you have to do this. जल्दी, 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 जल्दी. Then I'm going to tell you.
Sir, I think it's either A or B.
Sir, I thought it was D because they said
Oh,
further oxidation.
oh, okay. Under appropriate conditions, acidified KMNO4 can be used to break the carbon-carbon double bonds. Okay, or after these bonds, now you can see that they are saying further oxidation may occur. So it's mean that okay, this is hot KMNO4. This is hot KMNO4. Option A and B may they are saying okay, if you remember in cold KMNO4, I was telling you that only the diol would be formed. OH, 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 OH. If the diol is formed, so so why they are saying carboxylic acid is produced? Why? Option A is completely wrong. Completely wrong. Option B is completely wrong. If you are going to do oxidation with cold KMNO4, so how is that possible? K you will be having aldehyde and you would be having carboxylic acid. It's impossible. It's impossible. Okay. चलें जी. Now option C and D you have to decide. Option C में hot concentrated. Okay. And they are saying final oxidation products include aldehydes and carboxylic acid. Aldehydes and carboxylic acid. Let me tell you okay, what is the best answer. So if I'm going to break down this, you can see that carboxylic acid would be produced. Okay. So carboxylic acid तो दोनों में है. We have to decide between aldehyde and ketone. If you are going to break down this, so again you will see carboxylic acid, again you will see carboxylic acid. If you are going to break down this, you will see carboxylic acid and you will see ketone. You will see ketone. Okay. You will see ketone. Right? Okay. And if you are going to break down this, you will see carboxylic acid, you will see carboxylic acid. This would give you, this would be giving you ketone again. And you know, ketone cannot be further oxidized, but aldehyde can be further oxidized. So when aldehyde would further oxidize, so it would be giving you carboxylic acid. So that's why option D is correct. Because ketone cannot be further oxidized, as I told you in the last class. Okay, when you have this, like the two R groups are attached with the double bonded carbon, okay, so that would be ketone. And how the ketone is produced? Ultimately, you had this. Ultimately, you had this. So you have to see, okay, what is the reactant, and if you are going to oxidize this reactant, so what would be the product? So I told you that whenever you are going to use hot chemophore, so there would be rupture of double bond, and ultimately the ketone would be produced. But if you have one R and one H, then first aldehyde would be produced, and for an aldehyde we can do the further oxidation, so finally the product would be carboxylic acid. And I told you, if you have this criteria, the two hydrogens are attached with the double bonded carbon atom, so finally the product would be CO2 and water. That's why option D is correct. So it needs a lot of practice, as I told you. Whenever the examiner give this question, so ultimately he's going to ask in a random way. I was telling you in terms of, like, this is case number one, this is case number two, this is condition number one, when you have two R groups, when you have two hydrogens, when you have one R and one H. So this is not in a proper way. This is a random question. You have to identify by yourself. You have to identify by yourself कि यहाँ पर कौन सी condition apply हो रही है. Okay, am I supposed to form carbon dioxide? Am I supposed to form aldehyde? Am I supposed to form carboxylic acid? Or am I supposed to form ketone? That's it. Okay. तो थोड़ा सा टेक्निकल क्वेश्चन था ये, बट बाय द वे ऑप्शन बी इज करेक्ट इसका, क्वेश्चन 29 का. ओके. नहीं, अभी इसको छोड़ देते हैं हम. कैन यू टेल मी दिस? 26. 26. I'm going to give you only 1.5 minutes, then you are supposed to tell me, okay? Yes. How many stereoisomers are there in with this structural formula? With this structural formula. Anji,
So is it D?
how? How is it D? Anji, let's suppose I'm going to draw the structure, this displayed formula. Let's suppose I'm going to draw the displayed formula. This is CH3, this is CH2, 17 times. Oh, then C, then double bond C, then H, then H, then CH2 again 17 times, okay, and then C, then H, then OH, then C, then H, then CH3, then C double bond OOH. So it's going to give you cis and trans. So two isomer for this, and hopefully there is no any double bond except this. Okay. So and then what do you think? Then what do you think? Anji, this
So there's a
CH3?
chiral carbon where COOH is as well.
No, it's double bonded carbon.
Oh.
मैंने इसको चलो मेंशन भी कर दिया ओके तो this is chiral this is chiral okay yes then so two isomers are possible for this chiral center
Only four.
two for this am I right yes or no
So sir, one chiral center has two stereoisomers.
exactly because they are mirror images of each other they are mirror images of each other right okay
C.
C but the answer is D but the answer is D but the answer is D yes how how can you say the answer is D can anyone explain hmm? हाँ भाई समी क्या कहते हो समी ताहा what do you think ताहा आमिना ईमान शाफे सिमोना ताला ताला you are silent why
So is it
are you
because of
getting
these cis trans isomers?
I'm here, sir.
क्या कह रही हो ईमान थी ना ये कौन थी ये yes exactly it's due to the cis trans isomer so that's why the answer is it there is no any criteria for the chiral center there is only two there are only two chiral centers only two chiral centers there is no any other possibility so the only one thing is that you can draw the two cis and the two trans isomers for this double bond two cis and the two trans isomers remember you can see when we were discussing the theory so I told you to draw the cis trans isomer I was giving you this example different groups means that different groups just like that it's ch3 and it's H and ch3 like they are the same but in this question they are not the same they are not the same okay so if they are not the same so ultimately you can draw the four isomers for this ultimately you can draw the four isomers for this so 2 and then 4 so the total isomers are 8 but remember you have to look at the structural formula okay there is a double bond yes there is a double bond so The double bonded carbon contain different groups attached. Yes. This group is different and this group is different. So yes. This group is different and this group is different. So yes, it's going to give you the cis trans isomer. But but just like this structure, are they grouped the same or not? No, they are not the same. So it's going to give you the four isomers, like the two cis and the two trans. That's why the answer is D, like eight. You're not supposed to draw the structure. It would take you a lot of time. It's just an idea. You can apply on all the structures. Okay, we would be discussing other questions as well. You can see this concept. This concept works basically. Okay. Again, this would take your time. Again, this would take your time because they have given you the chlorine in this question. Chlorine. So obviously, if you have chlorine, so the probability is going to increase. You would be drawing the structure, multiple structures you would be drawing. In some structures, you can say the chlorine is present at the first carbon, second carbon, the two chlorine are the two chlorines are present at the first carbon, second carbon, third carbon. So you have to make the possibilities like the probability, and you can answer okay, how many straight chain isomer. This is very important information in this question the examiner has given you. Is straight chain isomer. You're not supposed to draw the branched ones. You are not supposed to draw the branched isomer, only the straight chain structure. So what do you think, okay, how many isomers are possible? And also they are saying you are only supposed to consider the structural isomer, not the stereoisomer. You are not supposed to consider optical, you are not supposed to consider geometrical, you are only supposed to consider the structural isomerism. Okay? Yes. So how many isomers are possible? Then I'm going to tell you. And in options A is 6, 7, 8, 9. Yes. What do you think? Haji. Then I'm going to draw this. Then I'm going to draw this, okay? Four carbons, है ना? Okay. I can attach one chlorine over here, one chlorine over here. I'm not going to write down hydrogen atoms. Okay, it's understood, obviously. So this is the first structure, the first possibility. Then I can make another possibility by writing this 1,2 dichloro. This was 1,1 dichloro. Okay. This was 1,1 dichloro. Okay. Then I can make this possibility. Then I can make this possibility. Okay, that this is 2,3 dichloro. This is 2,3 dichloro. Okay, and it's gonna be 1 and 4. So four isomers. One, two, three, four. Any other possibility? What do you think?
Two dichloro.
One, then two, then three, then four. Yes, कौन कह रहा था क्या हो सकता है? Yes.
Two dichloro.
Exactly. क्या बात है जी, क्या बात है भाई. 2,2 dichloro. Yes. It's 2,2 dichloro. Okay, this is the fifth possibility. And then what do you think? What should be the next possibility? Or yes, that's it. What do you think? Right now, so far, 1, 2, 3, 4, 5 isomers आपने बना लिए हैं. Yes. Is there any other possibility? Let me tell you something. It's 1,1 dichloro. It's 1,2 dichloro. It's 1, 4 dichloro. It's 2, 3 dichloro. It's 2, 2 dichloro. Anji, Anji. Yes, 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 yes. Yes. 1 and 3 is remaining. 1 and 3 is remaining. क्या कहते हो है ना? 1 and 3 is remaining. So this is 1, 3 dichloro. So how many isomers are possible? Six. Six isomers are possible. So the answer is A for apple. So the answer is A. Okay, easy है ना? It's not difficult यार. So easy. बट ऑब्वियसली आपकी प्रैक्टिस होनी चाहिए आइसोमर की. और दूसरा इन्होंने आपकी जिंदगी आसान कर दी बेटा कि they have mentioned that you have to draw only a straight chain structure. You have to draw only a straight chain structure. That's it. Okay. And question number 33. This is the last one. Question number 33. Can you do this? 33. जल्दी 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 फटाफट. Question number 33. हाँ जी.
Sir, is it B?
It's hot KMNO4 ना.
Sir,
So
keto?
कीटोन तो बनेगा ही नहीं यार. क्या कहते हो? कीटोन नहीं बनेगा. क्योंकि लेट मी
सर
टेल यू
एल्डिहाइड
दिस.
बन रहा है।
Sir, isn't it tertiary alcohol?
हाँ ना. एंड फाइनली कार्बो. ओ माय गॉड, हु इज टर्शियरी अल्कोहल? ना करो
सर
यार.
एल्डिहाइड
इट्स
क्योंकि
नॉट
ऑक्सीडाइज हो
टर्शियरी
रहा है, राइट?
अल्कोहल. ऑक्सीडाइज तो हो रहा है बट द थिंग इज दैट what would be the product? So okay, it would be breaking down over here. So that's the case. Then H and R. So carboxylic acid would be produced. कैसे कैसे कैसे? C double bond O, then OH, और उससे पहले CH2, then CH3. Okay जी. So कार्बोक्सिलिक एसिड. एक ही तो ऑप्शन है यार. आंखें बंद करके डी फॉर डॉक्टर. आंखें बंद करके डी फॉर डॉक्टर बिकॉज दिस इज हॉट. हॉट में हॉट में अल्टीमेटली what you are supposed to do, the double bond would be breaking down, okay, to give you this structure. That's it. सही है जी. Okay, so again paper 2 is remaining. Paper 2 is remaining, so we have to do paper 2 as well. Then inshallah we would be moving on to the next chapter. Okay ji? Set.